In the earlier video, you've seen that how is the front panel of a digital multimeter. Then you've also seen what is a resistance to voltage converter. Then you've seen what is the current to voltage converter. Current to voltage converter is also called as I to V converter, of course. Then now we move on to the block diagram of DMM. Yeah, so this is the block diagram of DMM. Let me take you through all the blocks initially. Let me start with the leftmost part. If you can see, yeah, so if you can see that you have somewhere over here written as test probes. So if you remember that on the front panel of the DMM you had those slots where you could connect the test probes. If you remember, I had mentioned that the common terminal will always go to the ground. So if you can see, this is the place where the common terminal will be connected, which is going to the ground directly. Then the second terminal will be connected somewhere over here. And of course then you have a rotary switch. The rotary switch could help you how exactly, or right, what exactly are you supposed to measure, whether you want to measure DC voltage, or you want to measure AC voltage, or you want to measure DC current, or you want to measure the resistance. So just in case you want to measure the DC voltage, then your rotary switch will be kept to a position where DC voltage is written. And then if you keep your rotary switch to the place where DC voltage is written, then your the input which you are applying, that DC voltage, will get automatically connected to the first block which is mentioned here, that is DC voltage attenuator. In case you are keeping your rotary switch to this place, that is the AC voltage, then that applied AC voltage will directly go to the will get connected internally. It will get connected to the second block, that is the rectifier and the attenuator. In case your rotary switch is kept to a place where DC current is written, then internally your block that is getting connected is actually the third block, that is the I to V converter. I to V converter in the sense current to voltage converter. And in case your rotary switch is connected to the fourth position, that is the resistance position, then internally the block will get connected, the block that gets connected internally is the fourth block, that is the resistance to voltage converter. Okay, so that's about these different blocks. And then if you can see that all these blocks, they are actually now going to the next block, which is where it is mentioned as analog to digital converter, or ADC. ADC is then going to the counter, and counter is then going to the digital display. Okay, so I have just taken you through all these different blocks. Now let me tell you what exactly is happening here. So let me start actually with this particular part where it's mentioned as analog to digital converter. This particular block. In ADC, or analog to digital converter, the name itself tells you that it takes inside an analog signal and gives as its output a digital signal. So let me tell you that there are different types of ADCs which are available or which can be constructed. So ADCs generally take inside DC voltage. So the ADC that you're taking inside, and the ADC that is taking inside as an input signal, is going to be a DC voltage, and the output which the ADC is going to give is going to be a digital voltage which is DC, right? So let me repeat that the input which this ADC takes is voltage, and it is DC voltage, and it is analog in nature, whereas the output which this ADC gives is again a DC voltage, but it is digital in nature. Hence it is called as analog to digital converter, because it is converting that analog voltage into digital voltage. But please do remember that the input is DC voltage and not AC voltage. So which means that the input which needs to go to this ADC is DC voltage, so that whatever quantity you are trying to measure at the input, whether it is DC voltage or AC voltage or DC current or resistance, whatever you are trying to measure, all of them need to be converted into DC voltage, because they need to be given to ADC. So let's understand what happens in the first block. Okay, so you are trying to, you've kept the rotary switch to the first position, which is trying to measure the DC voltage. Now because that the input quantity is already a DC voltage, you actually need not convert it again into a DC voltage. What you need to do is you simply need to apply the DC voltage from the first block. Yeah, so what you need to do is that you simply need to apply this particular DC voltage directly to the ADC. But then the only thing is that instead of applying it directly, we are giving it through this particular block, which is called as a DC voltage attenuator. Now what is this? It is simply that it is attenuating the voltage which is taken inside. The reason is that the ADC actually doesn't work on higher voltages, but the voltage which we may be applying might be higher voltage. That is the reason this block is simply attenuating the input voltage which is taken inside. I hope everyone knows that attenuation is just opposite of amplification. Attenuation, which means reducing the strength of the signal. So that the received DC voltage is then given to the DC voltage attenuator ka block, where simply the DC voltage is reduced in strength, and then further it is going as the output, and then it is going to the ADC. That is the first one. Now the second one, in the sense, if your rotary switch is kept to the second position, jahan pe you are trying to measure the AC voltage. So if you're trying to measure the AC voltage, then let's understand what happens. This particular AC voltage is now given to this particular block. If you can see, block pe kya likha hai? It is rectifier and attenuator. Why rectifier? Because ADC needs DC voltage, whereas we are applying AC voltage. So the AC voltage will be converted into DC with the help of a rectifier, and then it is attenuated, and then finally that attenuated DC voltage is given to the ADC. Now, next. Just in case your rotary switch is connected to the third position, that is, we are trying to measure the DC current ka value, because the multimeter can measure anything. It can measure voltage as well as it can measure current. So if your multimeter is trying to measure the DC current, then this DC current which is taken inside is given to the block which is called as I to V converter. If you remember, I to V converter is also the current to voltage converter, and current to voltage converter we've seen in the earlier video. So that current to voltage converter wala block is actually going to convert the incoming unknown value of DC current into an equivalent amount of voltage. Of course DC voltage, and then that DC voltage will then be given to, of course, the ADC. That's about measuring DC current. Now the next is the resistance measurement. So if your measured quantity is resistance, I mean the quantity to be measured is a resistance, then that resistance, this particular resistance is then given to this particular block which is called as a resistance to voltage converter. In the earlier video we've also seen what is a resistance to voltage converter. So a resistor which is acting as a resistance to voltage converter will be present inside this block. So in short, what it is going to do is, it is going to take inside this unknown value of resistance, and that will be getting converted into equivalent amount of DC voltage over here. That is at the output, and then that equivalent amount of DC voltage is then finally given, of course, to the ADC, as you can see. So in short, that whichever block is connected in the circuit, may it be the DC voltage attenuator or the rectifier and attenuator or I to V converter or resistance to voltage converter, sabka output is DC voltage, and then that is given to ADC. So ADC has taken inside DC voltage, which is analog in nature, and it is going to convert into digital. Why digital? Because if you can see at the end we have a digital display. So this ADC ka digital voltage output is then given to the next block, that is counter. Counter is simply used to compare the voltage that you have taken inside with some reference value, so that suppose if your voltage is 5.4 volt, so that 5.4 volt which is coming at the output of ADC is then compared with some reference value in the block which is called as counter, and finally then it is ready to get displayed on the final block which is called as a digital display. So in short, this is the way that the digital multimeter works, right? So left mein you have a rotary switch where you can select any of the functions, whether you want to measure voltage, AC or DC, or you want to measure current, or you want to measure resistance. Depending on whatever you are selecting, either of these 4 blocks will be selected. The job of each of these blocks is simply to take inside the incoming quantity, maybe voltage or current or resistance, and convert it into equivalent amount of DC voltage. Once that is done, that equivalent amount of DC voltage is then given to ADC. ADC converts the analog voltage into digital voltage, which is then given to the counter, and then the counter finally displays the same value on the digital display. So that's all about the DMM. Fine. So this is about DMM, and in the next lecture we will be studying about function generator.